So good morning, everyone. In the previous class, we have started our discussion with SCTP, and we have seen like what is SCTP, and when we consider TCP and UDP, we have also seen like SCTP is going to take best features of these two. Okay, that is what we have seen in previous class, and we have also considered what are the services of SCTP. Okay, today we will be looking at features of SCTP. So, any idea what are the features we had for TCP?
Reliability,
Then only one. Anything else? Yes.
flow control,
Okay. So flow control, error control, numbering
congestion
system,
control,
congestion control, numbering system. Then reliability also. So if you remember while discussing the services of TCP and features of TCP, I said at least 10 to 20% of the people will confuse, right? So again, I am repeating, don't confuse with services and features. As we discussed in previous class also, services means what TCP is providing to above layer or what SCTP is providing to above layer. Features means what qualities TCP has or what qualities SCTP has, because of which you are able to provide the services. For example, reliability, how you are going to get it. Okay, so stream oriented service, how you are going to get it. Okay, those are all because of the numbering system which we have, right? Okay, so we will see features of SCTP also. We will be discussing these things. So we have something called as DSN, transmission sequence number. Then we have stream identifier, then stream sequence number, packets, acknowledgements, flow control, error control, condition. Okay. So when we look at these things, anything that we have found in TCP also, what are the things we have seen in TCP?
sequence number, acknowledgement number, flow control.
Number we had flow control, error control, congestion control. Okay, we had sequence number, but we are talking about two different sequence numbers here. If you see here, we have two different sequence numbers. Okay, so can anyone guess what is this thing? Stream identifier. For that, you need to remember the stream, like what are the services we considered for SCTP. If you remember that, you will get what is the stream identifier. Anybody?
Sir, we have multi-streaming concept, no sir. So
Exactly.
which
When we consider SCTP, we talked about multi-streaming. We had from source to destination, we had multiple streams running. Okay, so we need to identify on which stream a particular packet has been transmitted, right? So for that we are giving stream identifier. Okay, clear, right? What is stream identifier? Then within the stream, we will be sending segments, or with respect to SCTP, we call them as chunks. In TCP, we call it as segments, right? Now in SCTP, we call it as chunks. So within each stream, we are going to send multiple chunks. Okay. So the sequence, like for example, this is 1, this is 2, this is 3, this is 4. Again, this is 1, this is 2, this is 3. Like that, within the stream, what is the sequence number? That is given by stream sequence number. But we also need to say with respect to original message, what is the sequence number? Okay, with respect to original, what is the sequence number that we are giving like this? Okay, you can consider like with respect to original one, this is 1, this is 2, but this is the third one, this is fourth one, this is 5, 6, 7. Okay, indirectly it means like whatever the original sequence we have 1 to 10, I can divide into different streams and I can transfer. Okay, so I need to tell with respect to original packet, what are the sequence numbers I have, and within the stream, what are the sequence numbers we have. With an example, you will be able to identify that clearly. But remember, we have transmission sequence number, stream identifier, stream sequence number, acknowledgement number. These are different numbers which we have in SCTP. So we have a note here. In SCTP, a data chunk is numbered using transmission sequence number. Okay. So previously, how we were giving this numbering? Segments were numbered using sequence number. In SCTP, chunks are numbered using transmission sequence number. Okay, so we have a relationship between sequence number and transmission sequence number. Okay. That relationship we need to identify. Then another note, to distinguish between different streams, SCTP uses stream identity. That is what we considered just a couple of minutes back, right? So we have from source to destination, if I consider, we are going to have multiple streams. Okay, to identify each stream, we are going to give stream identity. Then next note to remember is to distinguish between different data chunks belong to same stream, SCTP uses stream sequence numbers. Okay, so within the stream, we are going to send different data chunks. So how you will identify the order, etc., that is by using stream sequence numbers. Okay, so these are the three numbering things we have. Let us compare TCP segment and SCTP packet and understand what information we have in SCTP. Okay, so we are just repeating the TCP segment. We had source port address, destination port address. When we go with SCTP also, we have source port address, destination port address. Okay, and you all know what is source port address and destination port address. Within the source process, we are going to give some addressing, right? At transport layer, we are giving a port address for each and every process. Okay, so we are talking about that. What is the source port address we have, which is trying to communicate with destination port? Okay. Then we have something called as sequence number. But here, instead of sequence number, we have something called as verification tag. Okay. So we will see what is that verification tag. So there in TCP we have sequence number, but in SCTP we have verification tag. Here we have acknowledgement number. Here we have checksum. Okay. There some more details we have with respect to TCP, but we just have control information, data checks. Okay. So can you identify the difference? Can you identify the difference? If you see the difference, like source port address, destination port address, both are there. Sequence number is there, here verification is there, checksum is there, here we have checksum, but we are not talking about acknowledgement number, window size, urgent pointer, any options. Okay. The thing is, to include all these things, control information, we have something called as control chunks. Okay. So chunks means you need to consider a packet. A packet in SCTP. A packet in SCTP is considered to be chunk. Okay. So we have control chunks, we have data chunks. So overall, you can consider like most of the information, whatever we have in TCP, that we are removing and we are considering them as part of control chunks. Okay. So we will see what are the control chunks, what information we are trying to send through that. That we will see soon. Okay. So another thing, like we discussed in TCP, we are going to call them as TCP segments. When we go with SCTP, we are going to consider as packets or SCTP chunks. Anything we can call. Now let us try to understand the difference between SCTP and TCP. So when I consider the control information, we have seen like header length was there, okay, length information we have, and time to leave value was there, different flags were there, okay, urgent pointer was there. All these things were part of TCP header itself. But when we move to SCTP, they are covered in different control checks. Okay, the control information is part of TCP header, but when we consider SCTP, it is not part of SCTP header, but we are considering them under control check. Why we are doing like that? Because when we consider control information, all the information whatever we have in TCP, that we may not be using always. Okay, always we may not be in need of the control information which we have in TCP. So what we are doing is we are just considering them as part of control checks, so that whenever a particular control information is there required, only at that time we are going to use that particular check. Okay? So we are not wasting the bandwidth here. Data is considered to be one entity in TCP segment. Data is considered to be several data checks in SCTP. That is the difference. Options, that is part of TCP header. SCTP options are handled by defining new checks types. That means whenever we are interested in coming up with new option, then we need to define that particular check and we need to consider as part of new checks in SCTP. We don't have anything like options in SCTP. Okay. So what are the mandatory fields we have? With respect to TCP, if you observe here, from this point till this point we have mandatory fields. When we consider this, only this part is mandatory, right? Only this particular point is mandatory with respect to SCTP. So each line represents 4 bytes. So there we have 5 lines. So total 20 bytes of mandatory fields we have in TCP. When I consider this, 12 bytes of mandatory fields we have in SCTP. Okay, that is what we are saying. So with respect to TCP, we have 20 bytes of mandatory fields. With respect to SCTP, we have 12 bytes of mandatory. So why we are getting into a situation where the mandatory fields of TCP have been removed in SCTP? That is the question. So the reason is transmission sequence number is in data checks header. Previously we were using sequence number, right? Sequence number was there which used to identify from where to where we are sending the data. Using header length and this sequence number, we used to tell where to where we are sending the data. But when we consider SCTP, we are not considering that as part of header, but transmission sequence number is considered as part of data checks header. Okay? So by this time, you should be able to understand even the data check is going to have some header. Getting my point? In TCP, data is simple data. We don't have any header, separate header for that. Okay? We just had like TCP header attached with data. But in SCTP, I have SCTP header, control checks, data checks, and within data checks, I am going to have data. Okay, that is the difference. That is how 20 bytes have been modified into 12 bytes in SCTP. Okay, next, acknowledgement number and window size are part of control. Okay, acknowledgement and window size are part of control check. Whenever you are providing acknowledgement, then only I consider this. There is no point in having a particular field for acknowledgement even though you are not sending acknowledgement, right? For example, I am not sending any acknowledgement. So simply we are wasting 4 bytes within TCP, right? So we eliminated that and we are just considering that as part of control checks. No need for header length field because we don't have any optional field in SCTP. When we move to SCTP, we are not considering any header length. So there is no question of considering header length here because the field is fixed. It is fixed with 12 bytes. But in the case of TCP, 20 bytes, plus again we have some options. Okay. No need for urgent pointer because that is handled by some other data chain or some other control information. Okay. So because of all these reasons, we are moving from 20 bytes of TCP header to 12 bytes of SCTP header. Okay. And checksum with respect to TCP it is of 16 bit, but with respect to SCTP it is of 32 bit. Then those are with respect to header. Whatever we considered in the previous slide, they are with respect to header, how we have variation. Now in the next slide, we are looking with respect to some other things which are different when we consider SCTP and TCP. Okay. So association identifier. In the case of TCP, we don't have anything which identifies a particular connection. Okay? We have been establishing connection, but we don't have any mechanism which identifies what is the identity of a particular connection. That means whatever the connection establishment message you have, that can be replayed later. Let us say you started communication, you had data transmission also, later you terminated the connection. Okay? There is a chance where again you retransmit the same thing. You won't be able to identify whether it is retransmitted one or original one, because when we talk of, when you say like with respect to sequence number, I am going to tackle that issue, we cannot do, because how can you guarantee like for this connection I started sequence number 8000, I won't be starting with same sequence number for next connection. I cannot guarantee, right? Because we are completely selecting a random number, and I cannot say like the random number cannot be 8000 again. So when we go with TCP, there is no way in which you can identify identity of a connection. But in the case of SCTP, we are going to give a verification tag. That means in case in future you are coming in with same request with verification tag, you will be able to identify. Okay. Then we have multi-homing in SCTP. As we discussed in previous class, multi-homing is like each device can have multiple IP addresses, and a connection or association can be established with multiple IP addresses. But load sharing is not allowed when we consider multi-homing in SCTP. Only thing what is possible with respect to SCTP multi-homing is whenever there is issue with one IP address, I can stop that one and I can go with another IP. Okay? Like that, for fault tolerance itself, we will be using multi-homing pattern in SCTP. Then, with respect to sequence numbers, we have one sequence number in the header in the case of TCP. But when we consider SCTP, we have transmission sequence number, stream identifier, and stream sequence number. All these are useful in defining each data chain. Okay, but in the case of TCP, we had only one numbering system. Synchronization message and finish message need to consume one sequence number in case of TCP. Okay, but when we consider SCTP, we are considering them as part of control checks. Okay, so control checks never use a sequence number, whether it is PSN or SIN or SSN. Okay, that is the reason we said these numbers are part of data chain. Data chain header, these numbers are part of, like that we said, right? Because when we consider control checks, whether it is a connection establishment, connection termination, or we have some more things like echo, cookie echo, okay, acknowledgement related. So all those things we are not going to use any sequence. So that is what we need to identify. Okay, so clear about what are the differences we have with respect to SCTP and TCP, right? So we consider with respect to header, what are the variations we have, and we have also considered with respect to other features and services, what are the variations we have when we consider TCP and SCTP. Okay, they can ask a question, how SCTP is different from TCP, and how you can justify, like when we move from TCP to SCTP, we are reducing the number of bytes in header, but we are able to provide all the services. Okay, how means you need to explain all this. Yes. We just want to increase the capacity. We don't want to restrict with just 16 number. So in SCTP, control information and data information are carried in separate checks. We are not going to mix control information and data information. But in the case of TCP, we were having same. Okay, in the same packet we used to have it. Okay. So let me try to draw something here. Original packet we can consider, and here we are considering 3 streams. Let me redraw this. Okay, packet I draw like this. Streams. Three streams I have. Stream identifier you can see. Stream identifier 0, 1. Okay, I will give SI 0, SI 1, right? And transmission sequence number, if you see, it is starting at 101 and ending at 110. Okay, this is original packet. So you can consider like 101, 102, 103, 104, 105, 106, 107, 108, 109, 110. Okay. See, don't consider like we are going to have numbering like that in packet. When I take a message, I am going to divide into different data chunks. Okay, each data chunk is given a numbering. Let us say I divided it into 10 different data chunks. Each data chunk is given a particular number, 1 to 10, 101 to 110. Okay. Now let us look at each packet. First packet is there in which we have header, control chain. Then we are saying, as you can see here, we are setting 1, 2, 3 data chunks. Okay. So online, you are able to understand, right? What I am saying.
Yes, sir.
Only one response. Others are sleeping. They are able to understand or not?
Yes, sir. Yes, sir.
Okay. So first packet, if you see, first data chain, as we have considered previously, within the data chain we are going to have numbering. So TSN, transmission sequence number, what we are saying, that means we are going to consider this one, 101, 102, 103. These three data chains I am going to send as part of first packet. Okay, and you can see here stream identifier 0, stream identifier 0, stream identifier 0, and stream sequence number 0, 1, 2. Okay, that means within a particular stream, what numbering I am going to have. So by looking at stream identifier 0, you need to consider 101, 102, 103, 101, 102, 103. They have been sent through stream identifier 0. Clear? Okay. Next, let us go to second packet. Second packet, what happened? PSN is 104. That means we are talking about this one. 104. SSN is 3. Stream identifier is 0. Okay. SSN within the stream, this is 0, this is 1, this is 2. Next one, 104 is 3. That means I have stream 0, which is taking the information from first packet and a part of second packet. Right? Till this part, we are going to send through stream 0. Okay. Then in stream 1, what we are doing? 105, 106, 107, we are sending. Okay. Again, second stream also is carrying the information from two different packets. Okay. Now you should be able to understand the importance of stream sequence number. Why I am carrying only second packet information through stream 1, I may not be needing this particular stream sequence. But what is happening here? The same, like multiple packet information is being sent through same stream. So that is the reason what we are doing is we are giving stream sequence number also. Okay. So till 107 we are sending from SI1. In SI2, these 4 data chunks are being sent. Okay, and you can see SSL number, SSL 0, 1, 2, 3. When you receive at the other side, what you will do? First, I look at TSN, transmission sequence number. Then I look at SI0, SS1, sorry, stream sequence number. All these things I will consider and I will rearrange at the other side. Clear for everyone? How we are transmitting the data through multiple streams and what is the importance of real transmission sequence number, stream identifier, and stream sequence number? Clear?
Yes, sir.
Sir,
Okay.
can you repeat the SSN again, sir?
Which one?
Importance of SSN.
See, stream sequence number, if you observe, second packet and third packet is starting with a data chain which was carried on stream identifier 1. And it also has two data chains which are of stream identifier 2. Okay. So, indirectly, you need to understand a single packet is sent through multiple streams. Okay. A single packet, third packet is sent, a part is sent on stream identifier 1, a part is sent on stream identifier 2. That means 1 and 2 streams on which we are sending the packet. So at the other side, how you will differentiate whether this is part of second packet or first packet or third packet? We have total 4 packets, right? How you will differentiate whether PSN number 107 is part of second packet or third packet? That can be done by looking at SSN. Okay, so that is what we are doing here. Okay, that is the information about transmission sequence number, stream sequence number, and stream identifier. Data chains are identified by 3 things. We have also seen previously: transmission sequence number, stream identifier, and stream sequence number. PSN is cumulative number identifying the association. Stream identifier defines the stream. SSN defines the chain within the stream. Okay, as we consider with respect to original packet, the sequence number is PSN. Within the stream, the sequence number is SSN. And when we want to identify streams, we are going to talk about stream identity. Okay. Then next notice, in SCTP, the acknowledgement numbers are used to acknowledge only data chains. That means we are not giving any acknowledgement for control chains. Okay. We are not having any acknowledgement for control chains because control chains are acknowledged by other control chains. Okay. So for example, I have a control chain called cookie in SCTP. That will be acknowledged by cookie echo. Okay. Previously, when we send synchronization message, which is control message, we used to get acknowledgement. Right? Previously, we used to get like that. But when we move into SCTP, I'm not saying like SYN is same as cookie, but cookie is one of the control methods. When I send this one, we are going to have cookie echo, which is acknowledgement for cookie. Okay. So here we'll be having something like init INID, for which we will have init plus echo. Okay, we will see these things anyway. So now let us look at SAT. Any idea what is this SCTP?
Selective acknowledgement.
Exactly. So while discussing about acknowledgements, we talked about acknowledgement, accumulative acknowledgement and selective acknowledgement, right? Accumulative acknowledgement is part of TCP, and when we move to SCTP, we have selective acknowledgement. Okay. So let us look at selective acknowledgement. What are the things we have in this? First, we are going to talk about type. Okay. Type basically gives the information about what is the type of chunk we are considering. Okay. So for selective acknowledgement, the type value we are considering is 3. Then flag, we are not using that one. So we are keeping flag value as 0. And we are going to consider length of this selective acknowledgement. Okay. Then, any idea what is this cumulative PSN acknowledgement number? In the case of TCP, we used to provide acknowledgement number, which used to say what is the next expected sequence number, right? But in the case of cumulative PSN acknowledgement, we are not telling about what is the next expected sequence number, but we are talking about what was the last data chain received in sequence. Okay, that means 101 to 110, these are the transmission sequence numbers we are sending. Let us say till 105, without any issue, the receiver has received. Okay, 101, 102, 103, 104, 105. Okay, I didn't receive 106. Let us say I received 107. In that case, cumulative PSN number will be, let us say 108 also. Advertised receiver window plate. That means what is the window size I have at receiver. Okay, previously we were giving this information as part of TCP header, but now we are considering as part of selective acknowledgement chain. That means you need to think this is a separate control information chain which is there in SCTP just to send acknowledgement information. Okay. Then number of gap acknowledgement blocks, okay, which talks about the sequence of received things. Like I have received till 105, I have 106 which is a gap. Again I received 107. So how many gaps we have here? 1. Okay. So we will keep this one as 1. Let us say 107 and 108 appeared 2 times. Then I will say number of duplicates as 2. Okay. While discussing acknowledgements in TCP, we said selective acknowledgement of SCTP it is going to give along with acknowledgement number, it is also giving information about what are the blocks which are missing and what are the blocks which are duplicated also. Right. So you can see here we are talking about that. Number of gap acknowledgement blocks, number of duplicates which we have. Okay. Then gap acknowledgement block 1, starting at what is the offset. Okay. Let us say I have 105 till which I have received in proper order. I did not receive 106, but I received 107. With respect to 105, what is the position of 107? If I start 106 as 0, if I start numbering as 0, offset address, this will be 0, this will be 1, this is 2. Okay, after a gap 1 acknowledgement block is starting at 107. Okay, so we will give offset value as 1. So when the receiver, when the transmitter receives this information, it looks at cumulative acknowledgement, and cumulative acknowledgement tells us like we have 105 till which the receiver has received. Then it is saying like we have 1 gap acknowledgement block. So after that, let us say we have a gap. Then we are saying like gap acknowledgement block is starting at an offset 1. That means 106 I did not receive, but 107 I have received. Like that it would be coming to know. And this gap acknowledgement block is ending at what offset? So what offset it is ending? 2. So here we have 2. I don't have any other blocks. In case if I had block, like again 109 is not there, but 110 is there, 111 is there. In that case, number of gap acknowledgement blocks will be 2. Second block is starting at what offset? 4. Okay, we'll give that information again where it is ending. All those things will be given. Okay. Then duplicate, which is the one which are duplicated 107 and 108. So here I will say 107. Here I will say 108. Okay. So overall, if you see, we are talking about cumulative PSN, advertised window size, what is the capacity at the receiver, and number of gap blocks we have, and number of duplicates which we got. First gap block starting at what offset, second block where it is starting, where it is. Complete information we are giving in selective acknowledgement. And this is very, very important in case we want to understand flow control and error control in the case of SCTP. Okay, so you need to remember this particular selective acknowledgement chain. Okay. Okay. So is it clear? Selective acknowledgement concept?
Yes, sir.
Yes, sir.